Hello, hello, greetings, salutations, and welcome to Math on a Tuesday. It's Mr. Taco. Today we are diving into adding and subtracting to the thousandths place. Yesterday we introduced the thousandths place and dove a little bit into what it is. Simply put, it's just 10 times less than the hundredths place. 10 thousandths equals 1/100th, right? Just a continuation of our place value concepts that we've been working on. There's what you'll need. There's the I cans down there. I'll read them for you. I can understand that decimals are equal divisions of 1 organized in groups of 10. I can add and subtract decimals to the thousandths place. Now, before we really dive into adding and subtracting to the thousandths place, I want to review this a little bit because I'm still noticing some bobbles on exit tickets, okay? And the key with decimals, because we're in a situation like we are with whole numbers at times where you don't have the same number of digits in either of your terms that you're working with addition and subtraction, and we need to make sure we're lining up those places correctly so we get an accurate answer, right? Just like we can't do 378 minus 15 like that. What's the problem there? Right? This isn't 15 because we don't have it in the right place. 15 has 1 in the tens and 5 in the ones. This has 1 in the hundreds and 5 in the tens. So really, this is actually 150, which is a much different number from 15. Similarly, where's my eraser? There you are. Similarly, when you have something with decimals, you're not necessarily going to have the same exact decimal places with value in them in both of your terms. So if you have something like 16 and 4/10 minus 3 and 37/100ths, okay, your key for lining up your terms in their correct places so you get an accurate answer is here. The decimal point is always going to be between the ones and the tenths. Always going to be between the ones and the tenths. Okay, so what you can do when you set this up in vertical form and we're subtracting, let me get my operation correct, okay, is really make a concerted effort to put your decimal points directly lined up with each other. And in your answer, your decimal point will also go in that straight line. Okay, in fact, you could try this today of the first thing you do, draw out your, set up your structure and then line up the decimal points. And then what you're going to do is you're going to fill in your numbers based on where the decimal points are. So with 16 and 4/10, I see that the 4 is directly next to the decimal point. Okay, and then our 6 is on the other side of our decimal point in the ones place, and then we have 1/10 next to it. Okay. Likewise, 3 and 37/100ths. I see the 3 is directly next to the decimal point in the ones place. And then our 37/100ths goes to the right of the decimal point. And then, look who's here. If you ever have a situation where you don't have a decimal place represented, for instance, there's no hundredths here. And I gave it away by just saying that sentence. There's no hundredths. There are 0 hundredths. So make sure to use those zeros as placeholders if you have a blank spot either above or below in your addition or subtraction problem. Okay, that's going to help keep track of what we're doing here. Because in this case, right, I see a lot of this. I've seen a lot of this on exit tickets of going, oh, well, I'll just bring the 7 straight down because there's nothing there. 4 minus 3 is 1. 16 minus 3 is 13. What's inaccurate about what I just did here? It's in this spot. 0 minus 7 is not 7. Okay, that's why we need to regroup from the next place over. And that's why our 0 helps. If your 0 is here, then you can clearly see, oh, 0 minus 7 is not going to work So I'm going to need to regroup, take one of my tenths, and convert it into 10 hundredths. Now I can do 10 minus 7 is 3. 3 minus 3 is 0. And then 16 minus 3 is 13. So we end up with our accurate answer of 13 and 3 hundredths, right? Just the same as whole number addition and subtraction, right? And Ava's saying it in the chat, right? Just like whole number addition and subtraction. If there's a lack of a place there, there is 0 in that place, right? Same thing here, okay? We don't put it in the tens place here, but there is a 0 here. And if that helps you to subtract accurately, do it, right? 6 minus 3 is 3. 1 minus 0 in the tens is 1, right? Or you can think about it as a whole thing of 16 minus 3 is 13. That's okay too. Okay, similarly here, some people like to think of this as, oh, what's 40 minus 37? It's 3. Okay, but the 0 in the tenths is crucial in order to have accurate value. So when we do it in the thousandths place, it gets even more important to keep our decimal points lined up. So if you have something like, let's not even worry about whole numbers yet. If you have something like 748 thousandths plus, let's do minus. Subtraction seemed a little trickier, so let's do subtraction altogether. 748 thousandths minus 68 hundredths. Okay, 748 thousandths minus 68 hundredths. Okay. If I were to give this on an exit ticket, I would probably see at least one answer that looks like this. Of 66 hundredths, essentially treating them like whole numbers. Okay. The problem here is you don't have the same value when you end up doing it that way. Okay, because essentially what you're doing is you're saying 748 thousandths minus 68 thousandths. You're putting the 0 here, when in fact, because of our decimal point, our 0 goes in a different spot. So again, start your problem if this is tricky for you. Okay, start your problem with your decimal points. Just line 3 of them straight up. They're both zeros here, so we can just put zeros in the ones. And we can assume, because it's subtraction, that there's going to be a 0 in the ones as well, right? If you somehow end up with a whole number and you're subtracting, check for reasonableness. I'm seeing some of that too on exit tickets. Is you might have something like this, and then your answer is like 1 point something. If you're doing subtraction and your answer is greater than your largest term, the quantity you're subtracting from, something went wrong there. Try it again. Right? We're not dealing with negative numbers yet, so we're never going to subtract something and end up with more. So let's line up our terms. 748 thousandths. 748 thousandths minus 68 hundredths. Okay, and what goes here? We've got an empty spot below. If you ever see an empty spot below, put a 0 there. Okay, there's no thousandths here. Correct, there are 0 in the thousandths place. Then subtract straight down. 8 minus 0 is 8. In the hundredths, take a look here. Can we do 4 minus 8? I see a lot of people putting this. because 8 minus 4 is 4, but it's not the way subtraction works. It's not the same as addition where you can switch the addends and the sum stays the same. Okay? If we're finding a difference here, we have to go in order with subtraction. And we can't do 4 minus 8, so what do? We regroup. Grab one of our tenths, and then we're going to add 10 to our hundredths. Haven't changed the value, we've just taken one thing and moved it to a different category. We've made change. 14 minus 8 is 6. 6 minus 6 is 0. So we end up with 68 thousandths as our final answer. Okay, so again, really, really important to put this in vertical form and line up your decimal points. That's going to give you the best chance at having the most accurate answer. Okay, and it is very clear, based on your answers to your exit tickets, who's setting up their problem in an organized fashion and who's not. Because it becomes very clear very quickly when your places get all wonky and you're trying to subtract tenths from hundredths and hundredths from thousandths and so on. Okay? So let's go to our digital whiteboard and try a few. First one here. 847 thousandths minus 62 hundredths. Go ahead and set that problem up in vertical form. If you'll notice right away, you've got 3 decimal places in 847 thousandths, only 2 decimal places in 62 hundredths. So you'll need a 0. All right, and keeping our work neat really highlights and really shows, oh yeah, there's an empty spot there in the thousandths place with 62 hundredths. So now we make it essentially 620 thousandths by adding that 0. We haven't changed the value. And then subtract straight down. And you should end up with 227 thousandths. And really lean into that TH, thousandths, just to make it clear. Because 227,000 is a heck of a lot of a difference from 227 thousandths, right? That is a bank error I would be okay with if you wanted to give me $227,000 instead of 227 thousandths of a dollar. 22 cents versus 227 grand. Big difference. Okay, try this one. 93 hundredths minus 627 thousandths. So line up your decimal points. I am doing a lot of subtraction here because subtraction tends to be a little trickier than addition. And if you are lining up your places and lining up your decimal points accurately with subtraction, it makes addition that much easier. Okay, and I'm seeing more bobbles with subtraction, which is why we're spending the majority of this lesson on subtraction. Okay, take a look, fill in your values there. Add a 0 if you need to. Make sure yours looks like this. Okay, and you'll notice there, empty spot in the thousandths. So make sure you've got a 0 there to to really make it clear that it's not a matter of 93 minus 627, it's 930 thousandths. Essentially adding that 0, that's your way of making a common denominator if you think about it in a fractions context. Okay, so we're going to have to regroup. 10 minus 7 is 3 thousandths. 2 minus 2 is 0 hundredths. And then 9 minus 6 is 3 tenths with a 0 in the ones place. So you end up with an answer of 303 thousandths. Okay, check your work on that. Again, I've seen this before. Right, of bringing that 7 straight down, but it doesn't work for subtraction. You need to really do that 0 minus 7. So this is a no-go. All right, 2 more. 2 more. Where'd it go? There it is. All right, we've added some whole numbers here. 10 and 4 tenths. Hello. I'm definitely going to need some zeros for this one. 10 and 4 tenths minus 2 and 274 thousandths. Holy moly. Okay, Sinai with a reminder for us in the chat. When you're doing subtraction, remember we can't switch the terms. It's not like addition or multiplication. Okay, you've got to make sure you're doing them. You're keeping the 10.4 as the thing you're subtracting from, right? Otherwise, we get a much different answer. Okay, so line up your decimal points. Uh, 0 in the ones and 1/10, and then 4 tenths. And then in your bottom term, we have 2 ones and then 274 thousandths. And look at all that blank space up top, right? So here's what you're going to need. You're going to need some zeros. Hold those places, particularly because it's subtraction, and you're going to have to regroup. Okay? And this is a big one because it's a double regroup, right? Because you can't do 0 minus 4. You also can't do 0 minus 7. So you're going to have to go all the way to the tenths place. Take 1/10. Convert it into 10 hundredths. Then, again, double regroup. Take one of those hundredths. So this is now 9 hundredths. And convert it into 10 thousandths. Now you have enough to subtract. 10 minus 4 is 6. 9 minus 7 is 2. 3 minus 2 is 1. 10 minus 2 is 8. So you end up with 8 and 126 thousandths. Make sense on that one? Okay, subtraction with zeros where you have to regroup a lot can be tricky. Okay, and spoiler alert, I'm going to give you one more that's even tougher. Boom. 6 minus 326 thousandths. What the heck do we do here, Mr. Taco? There's no decimal point in the 6. Well, let's think about this logically. Where's the decimal point in 6? There is a decimal point there. Where is it? Because otherwise we're just stuck and we can't do it. We can, though. Where is that decimal point in 6? Think about what place our 6 is in. That's 6 what's. Mars says add a decimal point. Well, I can't just add it anywhere, right? I can't add it here. That makes it 6/10. Right? We've got to add it in the correct spot. So thinking about that ones place, we have 6 ones. The decimal point goes directly to the right of the ones place and directly to the left of the tens place. And you can see it here in 326 thousandths, right? We have 0 ones, so it's going to go right below the 6. And then we have 326 thousandths. Oh my gosh. What do we do? There's a bunch of empty space. Do we just go straight down and go, okay, 6 and 326 thousandths? No. We just added very effectively. And again, check for reasonableness, right? Can I have 6 and take something away and somehow end up with more than 6? No. Not reasonable for positive numbers. When we get into negative numbers, that's a whole other thing. Okay, so placeholders, 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 placeholders. How many tenths are there in 6? 0. How many hundredths? 0. How many thousandths? 0. Okay, theoretically, you could write zeros all the way till the cows come home, but because our value stops down here at the thousandth place, that's where we can stop to. Okay? Now, you're going to need a triple regroup. Okay, and let me show you the shortcut for a big regroup like this, when you've got a lot of zeros in a row. Okay? We worked on this a little bit last year, but just to remind you, okay, if you've got a big string of zeros like this in a row, here's what you do with them. Okay? You're going to regroup from the place that has value, the nearest place that has value. In this case, it's all the way to the ones. So I'm going to take one whole and make it 5 left in the ones. Then I'm going to go cross all these out. Your last place becomes a 10. Everything else becomes 9s. I know, right? And I can prove it, right? So 9 tenths plus 9 tenths, or 9 hundredths, plus 10 hundredths, or 10 thousandths, I should say, equals 0, 0, carry the 1 up, 0, carry the 1, equals 1. So we haven't changed any value there. Okay, essentially what we're doing is we're just doing all of those regroups in one step, where your place that you're ultimately regrouping to, in this case it's the thousandths, becomes a 10. You add 10 to there, and then everything in between becomes 9s, because you're essentially regrouping 10 and then regrouping 1, continuing on down the line. That was a very confusing explanation, but the shortcut is mathematically accurate. Now you can add. Or now you can subtract. 10 minus 6, 4. 9 minus 2, 7. 9 minus 3, 6. 5 minus 0, 5. So you end up with 5 and 674 thousandths. Yep, I'm seeing some add zeros. Absolutely. When I say right side, I mean left versus right, not wrong versus right. I do my best during these lessons to, when I mean correct, I say correct. And when I mean the opposite of left, I say right. If I ever mess that up, forgive me. But I try to be intentional about using correct when there's also a left-right thing going on. All right, so remember, key to the game here, key to the game when doing this exit ticket, line up your decimal points, and if you have empty space, because you don't have the same number of digits, like your values to the thousandths here, your values to the hundredths here, zeros as placeholders to keep all of your decimal points lined up and accurate. All right, give it a try. This will not be the last time we focus on adding and subtracting of decimals. It can be tricky. Okay, so try your best on it. Turn in your exit ticket, and then watch for my feedback when I return it to you, probably tomorrow. All right, thanks everybody for tuning in. Remember, be back here in about a half an hour for science. We're going to be going over concentration of solutions, part 2, and looking at some saltwater solutions today. All right, we won't be tasting them. It'll just taste like salt water. It won't be as fun as the orange soda from yesterday. We're going to do a little something different with them. All right, good luck, happy math, cheers. I will see you soon.